Good morning all. Today I am going to present the paper for design of 4x1 circular microstrip patch array antenna for WLAN applications. In this paper, the main objective is to design a circular patch array antenna and to improve the characteristics like gain, directivity, VSWR ratio and return loss. In this paper, we will discuss about these characteristics and the techniques we use to improve the parameters. The abstract of the paper is discussed that microstrip patch antennas consist of a thin flat rectangular or a circular patch or can be of any geometry, and there will be a dielectric substrate with ground plate attached to the opposite side of the substrate. The patch is connected in a feed position such that the emits electromagnetic waves into free space, and the antennas is useful in various fields like wireless communication, radar sensing, medical applications, as well as military applications. In this video, I am going to discuss about these parameters and the techniques which we have adapted to increase the characteristics of the antenna. The improvement of communication technology have been significant and show indications of slowing down. So an antenna means it collects radiation from a charge and the transmission line permits the current to flow out, but the associated electric field does not stop. There are various types of antennas like broad array antenna and end-fire radiators antenna. The microstrip patch is comprised of ground plane just under the dielectric material and a metallic overlay placed over the base, and the conductive material is used to design the antenna. Here, the circular microstrip patch antenna is designed in spite of the general regular antenna to increase the characteristics of the antenna such as gain, directivity, bandwidth, voltage strand gain ratio, and the return loss. The literature survey includes various papers, and the papers are performance analysis of microstrip patch antenna using different shapes at 2.45 GHz and design of a circular microstrip patch antenna and a circular shaped microstrip patch antenna for Bluetooth, Wi-Fi, ultra-wideband, X-band applications. We have analyzed these papers as well as the problem statement they provided and the methodology they adopted, and the results were taken into consideration to adapt the new transformation or the techniques in our current project. And similarly, there will be many more papers, and they are design of rectangular microstrip patch antenna at 2.4 GHz, as well as design, development, and performance analysis of spherical dielectric resonant antenna. After completing the literature survey, let us know about microstrip patch antenna. Microstrip patch antennas are low profile, conformal to planar and non-planar surfaces. They are simple and inexpensive to build or manufacture using modern technology. These are mechanically robust and can be mounted to rigid surfaces. In this image, we can observe that the rectangular microstrip patch antenna is present. There is a ground plane below and the substrate between the patch and the ground plane. The substrate acts like a conductive material and helps the antenna to increase its characteristics. The change in dimensions of the substrate may affect the characteristics of the antenna. And here, for the rectangular patch antenna, the feed is given and the feed is known as microstrip feed. Next, there will be circular microstrip patch antenna. In circular microstrip patch antenna, the radius of the patch antenna is considered and calculated using formulae. In this, we observe there is a microstrip circular patch antenna where the substrate is placed in between microstrip circular patch and the ground plane. Compared to rectangular patch antenna, circular microstrip patch antenna are easier to manufacture and show greater characteristics. Feed line. Feed line. It is a cable or a transmission line that connects the antenna with the radio transmitter or receiver. It feeds the radio frequency current from transmitter to antenna. We can observe in the above picture that the microstrip feed is given with the source, so it can transmit the radio frequency to the antenna, and the antenna radiates in all directions, and depending upon the directivity, the direction of emission of the radiation pattern changes. Coming to antenna design part, here the antenna design is based upon the radius of the circular patch. The radius of the circular patch is given with a variable a, and it is calculated as f by 1 plus 2h by pi epsilon or f ln of pi f by 2h plus 1.7726 whole to the power 1 by 2, where h indicates the height of the substrate, er indicates epsilon r indicates the dielectric constant, and the pi is the constant, and the value of it is computed as 8.791 into 10 power 9 by fr into under root of epsilon r, where fr is the operating frequency. Here we consider the operating frequency as 2.45 gigahertz. Initially, we have designed a single circular patch antenna, and we observed the characteristics of the antenna. To enhance the characteristics like gain and directivity as well as bandwidth, we have increased the number of circular patches. So we have designed the circular patch array antenna. Here the number of patches used are 4. So the name of the antenna is given as 1 cross 4 circular patch array antenna. And in patch array antennas, we observe both broadside array antenna and end-fire array antenna. Here, the spacing between the two circular patch is computed using the formula lambda by 2, where lambda is given as the wavelength, which can be computed using c equal to f lambda, where c is the speed of the light and f is the frequency. From this, we can compute the value of lambda. Here, in our project, the value of frequency, operating frequency, is 2.45 gigahertz. After substituting those values in the equation, we get the inter-element spacing as 62.5 mm, and we adopted the technique called quarter wave transformer. In this quarter wave transformer is used to divide the power equally to all the patches of the circular patch array antenna. To find the dimensions like length and width of the feed line widths, we compute using the given formula, which is shown in equation 3 and 4. Here there will be two cases. If the value of the ratio of width to height is less than or equal to 1, we adopt the equation which is in the form of 3, and else we use the equation 4. By substituting these values, we can compute the length and width of the feed lines, and the feed location plays a major role in antenna design. After computation using the mentioned equations number 7 and 8, we got x equal to L by 2 under root of epsilon r reference, y equal to W by 2, where L equal to 2 times the diameter of the patch and W equal to the 2 into diameter of the patch. Here we computed the feed location for the antenna. This is the design of our 4x1 circular microstrip patch array. In the given figure, we can observe that there are 4 circular patches and they are connected using the feed lines, as well as the quarter wave transformer is implemented. Here, this is the feed location. These are the feed locations which are computed using the before given formulas, and the feed transmission feed line is given to the source. Here, the quarter wave transformer divides the power equally to both the circular patch arrays. We can observe there are 4 circular patches and the length and the width are computed using the previous formulas mentioned. Here, if we observe, we can get the impedance, equal impedance of 50 ohm, and at the transmission feed line we get a input impedance of 50 ohm, and by using the formula we get the equivalent impedance as 70.7 here. This is the isotropic view of 4x1 circular patch array antenna. After designing the circular patch array antenna in the HFSS tool, which is high frequency simulator, we got the voltage standing wave ratio as 0.96, which is far closer to the ideal ratio, and the return loss observed at 2.45 GHz is around minus 26. The gain of the antenna is 8.60 and the radiation pattern are as shown. Similarly, the directivity of the antenna is 11.85 and the radiation pattern of the directivity is shown. The parameters like gain, directivity, return loss, VSW are computed and obtained in HFSS software, and the obtained values are: the gain is 8.6, directivity is 11.85, return loss is minus 27.93, as well as the VSWR ratio is given as 0.95. In conclusion, the 1 class 4 circular patch array antenna is designed using Ansys HFSS tool, and it is simulated to obtain the antenna parameters. In this design, we operate for edge fit technique as well as quarter wave transformer. These techniques have enhanced the results, the fields like gain, directivity, reflection coefficient, as well as the return loss. Here, the linear data flow from node towards the control node in WLAN applications, which is directional with other network antennas. These applications require extremely directional antennas. Wideband antennas are in high demand, so microstrip antennas have a limited bandwidth and poor efficiency, and the state of substrate has a big impact on how well they work. Due to this, the circular patch has an advantage over the rectangular one because they do not have high input impedance around the circuit, which is a drawback. Many antennas have been the subject of constant study to improve them and develop them more portable to be replaced in all fields. This antenna is mainly useful for wireless local area network applications. Thank you.